23. For the polynomial, 1, 0 is given. Find all others. And we've been given p of x equals x cubed minus 3x squared plus 7x minus 5. And we're told that positive 1 is a 0 of p of x. We need to now find the other zeros. All right, so this is similar to what we were doing in questions 21 and 22, except now instead of simply finding the factors, we're finding the zeros. So we're taking the factors themselves, so we will still find the factors and then set those factors equal to 0 and solve. So we're taking it kind of one step further than questions 21 and 22. But for this first part, we're going to start with synthetic division and use positive 1. All right, we know with synthetic division we have to be in descending order of powers and that we can't be missing any terms. So let's see, we go from 3 to 2 to 1 to none. So we're in good shape there, not missing any terms. So we can go ahead and bring our coefficients right down. So we have 1, negative 3, positive 7, and negative 5. Let's bring that first number down and multiply. 1 times 1 gives us 1. If we add vertically, negative 3 plus 1 gives us negative 2. 1 times negative 2 gives us negative 2. Adding vertically, 7 plus negative 2 gives us positive 5. Multiplying, we get positive 5. And when we add vertically for the last time, we get 0. And again, we would expect our remainder to be 0 because we are synthetically dividing with a 0 of the polynomial. We were told positive 1 is a 0, which means when you synthetically divide, you get a remainder of 0. The reason we did this is because we want the quotient of this synthetic division. Recall, this is going to become x squared minus 2x plus 5. We started with a third degree polynomial. We used synthetic division to get to a second degree polynomial, and now we're going to use factoring to find out what this quadratic equation breaks down into. All right, we could try using trial and error or the AC method or scissors method, but you will find that this particular polynomial can only be factored with the quadratic formula. So let's recall what the quadratic formula is. We have x equals negative b plus and minus the square root of b squared minus 4ac divided by 2a. And based on the quadratic here, we can see that a is positive 1, b is equal to negative 2, and c equals positive 5. So we're going to take these three values, plug them into the quadratic equation, and see what happens. So we have x equals negative b plus and minus the square root of b squared minus 4ac all divided by 2a. This gives us x equals positive 2 when we distribute, plus and minus the square root of, well, let's see, negative 2 squared is positive 4, and then minus, well, 4 times 1 is positive 4 times 5 is 20, so 4 minus 20 is negative 16, so we end up with negative 16 under the radical, all over 2a, and oops, I forgot to fill in the a, didn't I? So a was 1. So 2 times 1 is 2. All right, we can see that we have a negative under the radical, so we know we're dealing with complex roots here. So what happens now is we get 2 plus and minus, and the square root of negative 16, well, we know what the square root of positive 16 is, right? Positive 16 under the radical comes out as a 4, and then we know the negative comes out as an I all over 2. And when you can reduce these three numbers, go ahead and reduce these three numbers. And so this is going to become 1 plus and minus 2i. So these are the two additional zeros that we have for this polynomial in addition to positive 1 that we were given. So our zeros are 1 and then 1 plus 2i and 1 minus 2i. Remember, this is kind of written in a contracted form, but this plus and minus tells you that we have two parts, right? We have, if we were to expand this, instead of the plus and minus, you could write 1 plus 2i 1 minus 2i, but oftentimes you will see the plus and minus combined into that simple plus minus notation just to save room. All right, but when you write it in expanded form, we have our 1 plus 2i, 1 minus 2i, and then in addition to the 1 that we were given, we now have 3 zeros, and we would expect 3 zeros, right? We started with a third degree polynomial, which tells us we should have 3 zeros at the end. All right, there's number 23. I will see you at number 24.